They use echolocation to explore their habitat and produce an unpleasant scent to avoid being eaten by cats. But the common shrew has another survival trick as winter approaches. Its skull shrinks and then regrows in the spring. Dubbed Dennell's phenomenon after the scientist who first spotted the effect, the shrinkage has previously been studied by looking at the skulls of shrews that died at different times of year. But since the changes weren't followed in the same animals, it was not clear whether other factors might be responsible, such as smaller shrews being better able to survive the winter months. Now researchers say they have finally shown the phenomenon is real. Now for sure we can say this is happening within individuals. We can really talk about the shrinkage and regrowth, said Javier Lazaro, co-author of the research from the Max Planck Institute for Ornithology. The phenomenon, he adds, appears to be an unusual way to prepare for the harsh months of winter. These animals cannot hibernate and they cannot migrate and they live in a very seasonal environment, so they need some alternative strategy to deal with winter, said Lazaro, adding the shrews need to eat near constantly to survive and that smaller animals need less food. If you shrink an organ like the brain, which is disproportionately more expensive than other kinds of tissue, you might save energy, he said. Writing in the journal Current Biology, Lazaro and colleagues from Germany and the US report how they captured shrews of the species Sorex araneus, or common shrew, between summer 2014 and autumn 2015. The pygmy shrew, Sorex minutus, which also undergoes Dennell's phenomenon. Photograph Christian Ziegler. The team measured each animal's body mass and took X-rays of its head while the creature was under anesthetic. The animal was then microchipped and released back to the same spot. In total 37 shrews were captured more than once by the team, allowing the researchers to explore changes in the skull size of individual creatures as the seasons changed. The results reveal that the animal's body mass changed over the year. During the autumn it fell by 17.6%, before increasing by 83.4% in the spring, ahead of the onset of the breeding season. However, the animal skulls also changed in size, with the height of the shrew's brain cases decreasing just over 15% on average during the autumn, before regrowing by 9.3% during the spring months. What's more, while shrews generally don't live for much more than a year, data collected from a small number of elderly creatures reveals that they appear to undergo a second shrinkage in skull size as they approach a second winter. The fact that they shrink a second time in a second winter really suggests a correlation between seasonality and the skull size and not just an aging effect, said Lazaro. But, he added, mysteries remain, not least why the brain case does not completely regrow in adults in the spring, leaving them with a smaller skull than juveniles despite having the greater body mass, how exactly tissue is reabsorbed to generate the shrinkage, and what is driving the effect. We don't know to what extent this is genetically programmed, and to which point this is influenced by environmental factors, said Lazaro, adding that his current research is looking at how the brain itself also shrinks, and the effects of such changes on the animal's cognition and behavior. But, it seems the common shrew is not alone. Research has revealed that other species of red-toothed shrews as well as weasels appear to show Dennell's phenomenon. Dr. Alan McDevitt, a shrew biologist from the University of Salford who was not involved in the study, said that the research highlighted the drastic changes some species of shrew undergo to cope with the cold. But, he added, the research also threw up conundrums about how such animals might respond to climate change, and might also have ramifications for human health. Dr. Anna Champneys, an expert in small mammals at Nottingham Trent University, described the study as fascinating. If scientists can work out how skeletons grow and shrink, it will aid our understanding of skeletal diseases and could potentially provide a cure one day, she said.